Neural networks are algorithms capable of learning to solve complex tasks. In recent years, they have become the dominant machine learning paradigm, and they are tremendously useful, which is why they're everywhere, from inside your smartphone to self-driving cars. Imagine I challenged you to write a program that can distinguish between a person, a dog, and a car. If you actually try to implement an algorithm like this, you will soon realize that it's virtually impossible to handcraft it. And that is where neural networks come in, because they can learn to solve this problem without specification. At their very core, neural networks consist of information processing units called neurons, which are mathematical functions. So they take an input, like an image of a car, and return a new representation of that data. When you combine many of these neurons in a large network and let the information flow from one neuron to another, and do this many times, emergent behavior can arise, allowing the neural network to figure out that the image actually shows a car. The big idea behind neural networks is that the behavior of the neurons is learned. So it's not static, but very dynamic, and it adapts to what is asked of the neural network. Essentially, this means that the way the neurons process information can change. Mathematically, you can describe this by using parameterized functions. These are mathematical objects that have some basic structure, but the specific behavior of these functions depends on some learnable parameters. Hence, when we say a neural network learns, what we are actually saying is that we are changing the parameters of the neural network in a way such that the algorithm exhibits the wanted behavior. There is actually a nice way to think about the way the parameters are adjusted. Say I release a marble into a bowl. Then the marble will automatically find the spot where it has the least energy. Similarly, we can define an energy function for the parameters of our neural network, and the algorithm will try to minimize that energy function, called the loss. This process, called gradient descent, is governed entirely by a single equation, and it gives rise to the beautiful, complex, and emergent behavior of neural networks.